Hello everyone. We have already discussed importance of Hadoop framework. Let's now discuss Hadoop Distributed File System. Hadoop Distributed File System HDFS is Hadoop's implementation of Google File System. HDFS objective is to provide a huge amount of distributed storage that is reliable and scalable. It supports huge amounts of reliable storage at the expense of the following. The first one is that data written in HDFS is write once and read many times. It only enables a set of operations such as read, write, append, delete only. It doesn't support updation of data or overwriting of data. Second one is that data can be read sequentially with high performance, but random seek will suffer performance. Block size defines the minimum amount of data that can be read or written. HDFS is also a block structured file system. Data is divided in blocks and are distributed over clusters of computers. Here, the only difference is that block size is much larger than normal file system. Block size of HDFS is 64 MB by default. It can be configured as needed. HDFS works in a master-slave pattern. NameNode is the master. It maintains metadata as well as the file hierarchy. NameNode maintains two files, the namespace image and the edit log. The namespace image provides the structure of the file system. Edit log provides the log of changes made to the image. Secondary NameNode is a separate system that can be used in case of NameNode failure. It is worth noting that secondary NameNode cannot take over NameNode in case of failure. Its actual job is to periodically check the state of a NameNode. For this purpose, it keeps a copy of the namespace image and edit log in its memory. Whenever there is a failure, the edit log is merged with the namespace image to restart the NameNode. DataNode is a worker node that stores and provides access to data when asked for. It periodically sends the heartbeat signal to the NameNode specifying the blocks it holds. It helps NameNode in tracking the data blocks. It is true that data is spread across clusters of computers and hence the amount of data that HDFS can store is huge. But when data is spread across different machines, there is a good chance of data being lost in case of DataNode failure. HDFS provides replication of data to take care of this problem. By default, there are 3 replicas of a block on Hadoop cluster. In essence, it means that a data block is stored on 2 other data nodes apart from the original data node. So, even if one of the data node fails, data can be retrieved from any of the other 2. Hadoop runs on clusters of computers spread across many racks. Network bandwidth between systems on the same rack is greater than bandwidth between systems in different racks. NameNode uses a Hadoop rack awareness process to resolve the rack ID of each data node. So, when we are using rack awareness, how can we place the replicas? Can we place all the replicas in the same rack? Hadoop uses a simple policy of placing replicas on unique racks. When a replication factor is 3, 2 replicas are placed on one rack and the third one is on different rack. To reduce read latency, HDFS tries to satisfy a read request from a replica that is closest to the reader. If a replica exists on the same rack as the one that is trying to read, that replica is used to satisfy the read request. So now we can summarize the HDFS architecture. You can see that HDFS architecture works with two different types of entities, NameNode and DataNode. In this figure, you can see that the data is spread across 5 data nodes which are grouped into 2 racks, rack 1 and rack 2. And also we can see that NameNode takes care of the metadata related to the data blocks. So now we have understood the HDFS architecture.